Chapter 1.1, we're looking at parent functions and transformations. So we're going to do an exploration. We're just going to take a look at these names here of functions. We have constant, linear, absolute value, quadratic, square root, cubic, reciprocal, exponential, and then we have some equations here. We also have some graphs. So I would like you to take a moment, pause the video, see what you can figure out from what you remember from previous math classes, and see if you can try to match the name to one of these here. So for example, let's say constant. You look at this and you say, okay, I think the constant is G. Now, I'm going to tell you it's not G, but if you thought it was G, then you put it here. You write G here. And then you look, okay, what is the equation for that? And then maybe you think the equation is here. So you write G there, right? So that's everything that pertains to the name, the graph, and the equation. Now, G is not correct again, but just wanted to show you how you would fill this out. So pause the video, see if you can fill this out on your own, and then I'll go over it in just a moment. Okay, so hopefully you tried this out, and maybe you start with what you know. Now linear, let's maybe start with linear. Linear is a line, and so while this does look like a line, this is also a line here, F, and so these are parent graphs as well. So when you think of the equation of a linear equation, it is actually F here. So let's do that. The equation, I didn't want to get to that too soon, is here, y equals x. Now, if you think about it, it's y equals mx plus b. So number one, it is at the origin, which is 0, right? So that's our y-intercept. Our slope is really just 1 over 1. So our parent functions for all linear functions is y equals x. Now let's look at the absolute value. Maybe you know what the absolute value picture looks like. That one is A here. So absolute value is A. And then the equation for that is y equals absolute value of x here. All right, so we got A. Let's look at quadratic. Quadratic is a parabola. So that's going to look like here, letter H. So that's H, quadratic. And the equation for a quadratic is an x squared right there. Next, let's look at constant. So I did say that, yes, this looks like a line here, letter C, but that's a constant. So that is letter C. And then number 7, y equals 1, that is our constant, okay? Y equals 1, so it's a horizontal line at 1. And let's look at square root. So remember, square root looks like this. So that is going to be B. B, square root for B, and then the square root is here, so I did show that. So square root of x, that is B. Cubic, so cubic, think about x cubed, right? That is letter E right here. Cubic is E, and that equation is here. So x cubed is our cubic. Now, exponential, you might know, or reciprocal. Exponential, let's start with that one. Exponential, what did we not choose yet? That is going to be letter D here. So maybe if you had some chemistry or some science, we talk about exponential growth, it looks something like this. So letter D, and that equation is number 6, 2 to the x, where the exponent is in the exponent is the variable. And then the reciprocal function is the last one. That is G right here, G all the way at the bottom. And so that is going to be G. And then the last equation is 1 over x. Now, these are all things that we're going to go through in the entire year of Algebra 2. We will definitely study all of these. Our focus in the first chapter is going to be on linear and absolute value. We'll use a little bit of quadratic as well, but those are the ones we'll focus on first. Chapter 2 and Chapter 3 will definitely focus on quadratics as well, and then you'll see a bunch of these throughout the year. Now, just looking at the graphs, what are some of the characteristics of some of these basic parent functions? So all I want you to do is take a look at these graphs, and what do you notice about the graph? So pause the video for a minute and see what do you notice. So maybe some things on here is that you see that most of them pass through the origin or touch the origin in some way, right? So most of them do. Another thing is maybe that they are symmetrical. They are symmetrical like here. It's symmetrical across the y-axis here. It's like a mirror. Same thing you could say for here. And then as well as the parabola, it's symmetrical across the y-axis. You actually also have this type of symmetry here where it's symmetrical across the origin. So let's just kind of write a few of those things. So most go through the origin. Most go through the origin. Most are either symmetric. Most are symmetric either at the origin or even the y-axis. So just some general things, and maybe you notice some other things as well. So now that we've done, this is the first part we did on the top part. Let's take a look at some core vocabulary. So a function describes relationships between quantities. It is a relationship where each input has exactly one single output. A domain, so if you remember domain has to do with our x values. So domain is a set of possible x coordinates for a function. It's a set of inputs for a function. Range is a set of possible y coordinates for a function. It's a set of outputs for a function. A parent function is the most basic function in a family. Functions in the same family are just transformations of their parent functions. So we're going to take a look at transformations, but let's first look at some parent functions. So constant is just in our book. It says that f of x equals 1. So anything that's different than that, that is a transformation. Now the graph, remember f of x is really just y equals 1. And so that's our horizontal line at y equals 1. Our domain, thinking about the domain is all of our x values. And so our domain in this case is all real numbers. So you can say all real numbers. You could also say, in interval notation, we can say it's negative infinity to infinity. The range in this case, the range is we only get y equals 1 in this case. So y equals 1.